Hi, I'm MGutshall with Land Studies. We're an environmental planning and restoration firm in Lititz, Pennsylvania. I wanted to talk to you about a topic that's very important to us as well as the state of Pennsylvania, and I believe the Chesapeake Bay as well. We happen to be standing here in the Chickies Creek watershed and in a tributary to this, and what we are looking at here is the issue of this legacy sediment and a term called floodplain restoration that I want to talk about. We have over the years have worked with several different folks looking at and assessing watersheds from a standpoint of sediment transport, non-point source pollution, stream restoration, how these things affect the Chesapeake Bay, and what Pennsylvania's role is in all this as well. And one of the areas that we came up with was taking a look at the stream restoration, not only from a stability standpoint, but how this could be done in a way to restore the historic floodplains. And several different folks, including the professors, Walters and Merritts at Franklin and Marshall, and Dr. Art Parola at University of Kentucky, and our colleagues at Land Studies, Ward Oberholzer, have spent a lot of time on this. And what we found is we have a huge amount of sediment in our systems that were related to historic events. And we happen to be standing here in an area that used to be an impoundment of a mill dam. And the mill dams here in Lancaster County, there was hundreds of them. This just happens to be one of them. So this entire flat, plateaued landscape is actually an area where 6 to 8 feet of impounded water used to be that drove a mill several hundred feet down here, a mill wheel, and there was a dam down there. And what ended up happening is the dam collected a lot of sediment associated with land clearing actions, and when the area was forested, the trees were cut down, and huge amounts of sediment in an episodic one-time event would fill this basin depression over hundreds of years. And the dam is now gone, and what's left is the legacy sediment. And this legacy sediment has several attributes to it. It has loadings of phosphorus and nitrogen, but it also has thousands and thousands of tons of sediment that are now becoming available to our watershed as the stream starts to erode laterally. One of the attributes to the floodplain restoration is dealing with an alternative way of looking at stormwater. Regional stormwater management has been a topic that we've been talking about over the years. The legacy sediment has provided a huge amount of volume displacement in our watersheds. And as you can see in this tributary here, we've got 6 to 8 feet of the legacy sediment here. One of the goals would be to open this up or remove that sediment so that stormwater from a regional standpoint could be addressed with the volume, the sheer volume of storage here, as well as the area that has been buried has a permeable layer of organic material, and water can infiltrate through these areas. We happen to be in an area just north of Mannheim that experiences a lot of flooding, and there the folks that have been engaged, whether it be the local watershed and some of the town leaders, have been looking at ways to offset stormwater problems that are creating some economic hardships for their borough that has traditionally been dealt with on site. This is a way to deal with stormwater from a regional standpoint. Just right around the corner, what I want to do is show you an opportunity or an area that this tributary has been degraded by the legacy sediment issue, and it'll be a better chance to just show you what the banks look like here. If you notice here, we've got about 5 feet of legacy sediment that has been exposed where this used to be in an old mill pond. So the stream, the tributary, has cut down, and the elevation of the original channel before it was buried by the legacy sediment was right below this clay layer. There's a clay layer about 12 to 14 inches here, and right underneath here is where the old stream channel used to be. And what we have is an area of clay layer where the fine sediments dropped out once it hit a pond, the ponded area that we talked about. And so the fine sediments buried the original historic layer. And the historic layer is critical to understand because that's where there was organic debris. The organic debris that was here was a thin layer, and I can't reach down to it completely, thin layer that had a wetlands growing in it that allowed water to go through, so it infiltrated the area. There were wetlands here, and the areas that were immediately on top of it is this clay layer and then this loamy material. And you can see the significance of this loamy material here because it's very fine and it erodes very rapidly. So what you have is, and again, a very small tributary, look at the amount of erosion and degradation occurring in this tributary, a very small tributary, mind you, and look at the amount of sediment that this tributary is actually bleeding out or eroding laterally because it's trying to get back to its stable condition. Here we are looking at a cherry tree. It looks like a cherry, that box elder, and we got major roots exposed. Okay, and so what's going on here is you got trees that are on top of 4.5 feet of legacy sediment that are being undercut, completely undercut. So even some of the larger trees, regardless of how big they are, if you get underneath the roots similar to this, there's no way for that tree to hold up. It comes down, it blocks the channel, and it creates additional erosion on the banks, and then the bigger trees actually get lodged underneath our bridges that create a flooding problem here. Part of the legacy sediment profile here that we can't really see, we can see the eroding bank here, but we don't see is this area is a capture area of a lot of nitrogen and phosphorus, especially phosphorus, and phosphorus attaches to the soil particles. So if we look at historically what happened here, this whole area was a collection point for a lot of our waste, a lot of areas that are a lot of opportunities that really compiled a lot of the pollution that's in this bank, especially phosphorus here, that is built up in this legacy sediment bank, which is eroding. Speaking about the trees, we've got tree plantings on the top in a typical restoration. A lot of riparian plantings get put in, buffers, which is a good thing. It's a great thing for the environment if it's at the right place in the landscape. And this is an example of where there's a tree. This tree is probably 15 to 20 years old, and it's on top of the legacy sediment bank here of the profile. And what's happening is it's being undercut. So the function of these roots, of the things that a riparian buffer does, is really not happening here because it's not attached to the stream elevation. And this would be a typical scenario of trying to solve a symptom as opposed to really addressing the problem. The problem here is we've got a landscape that has been buried by 5 feet of sediment. And the symptom is we want to plant trees on the top to stabilize this. And this is really the end product of trying to patch a problem with tree planting, which I think a lot of folks are trying to do the right thing, but this is going to be the result. And what we will be seeing is the solution is to take this legacy sediment out and then take these trees and put these roots where they belong, attached to the original floodplain, so the streams are then stable and the nitrogen uptake and the phosphorus trapping are all in one spot. So I think we're just off in this case by about 4.5 feet. Hi, here we are at the middle of the Banta Stream floodplain restoration, Lidditz. The project was done 4 years ago. We've got approximately 3,000 linear feet of stream that was restored, as well as the floodplain was restored. And what I want to do is show you a few things here. We've got several things that we did as part of this. As you can see, we put in habitat features for in-stream habitat, as well as grade control. This is a rock vein structure. And you notice that along the stream and through here, we really don't use a lot of rock. It's mostly the dynamics of the stream working with the restored floodplain. The floodplain restoration, as opposed to a stabilization, is where we cut down the legacy sediment here and we've relocated the channel. The channel used to be over on the foot of the hillside that was the mill race. And in many places in Pennsylvania, a lot of our streams are actually encased or entrenched in the old mill race that fed the mill dam. So what we did was we relocated the channel in the middle of the valley where it historically was and where it belongs, and that has provided the opportunity for the stability of the stream then to get out of its banks and reduce the stresses on the channel and occupy the floodplain. Here we are taking a look at some of the benefits of the floodplain restoration outside of the stream corridor itself. We're on the restored floodplain where we've got a riparian buffer zone that has been planted, where 4 years ago we had a 12 to 18-inch seedling, rooted seedling that was put here, and as you can see, we've got a sweet gum here that's doing well, 5+ feet, and the majority of the survivability that we're seeing is a lot higher on these restored floodplains versus the non-restored floodplains, because the root zones are attached to the groundwater area. Another area that is a really big benefit from this project and this technique, if you see the sedges and the rushes here and the herbaceous wetland plants, the real neat thing about this is these were not planted here. These came in naturally because of the elevation that we excavated to had a historic seed bank that was part of the floodplain. We were able to get close enough to release these seeds, and we created 7.5 acres of additional wetlands on this site as a result of doing the floodplain restoration. This provides habitat for the turtles, amphibians, reptiles. It also provides habitat for things like pheasants that we're losing a lot of in our state. We've got a big diversity of plants as well. This isn't a monoculture. There's a big diversity of biodiversity that's occurring within these areas. One last function here is when we have thick wetland vegetation, it helps trap the sediments that come off, that comes out of the stream during frequent events, and that traps some of the sediment, in which that's what we want to occur, because there's phosphorus attached to that, and that becomes part of the system as opposed to going into the bay. Now, one of the interesting components of doing the floodplain restoration is its opportunity to bring in the market or the private sector into paying for something like this, and why would they be interested in doing that? We've been fortunate in the past, over the past 7 years, to have state and federal dollars to help with this, and it's seed money. There's issues such as regional stormwater management, groundwater recharge, the creation of wetlands, nutrient issues that are affecting the Chesapeake Bay strategy, and in Pennsylvania, issues in the Act 220, Act 167, Act 537. These are all issues that we are going to be spending a lot of dollars on, solving problems. Let's take a look at a different way. This project shows that it can be done differently to provide offsets for stormwater volume, getting water back into the ground. Lots of big box developments or school districts are spending $500,000 or more to deal with their regulatory compliance of stormwater and putting water back into the ground, utilizing holes in the ground with rocks and pipes. There's a better way, and you're looking at it. This has an opportunity not only to solve that economically, but to provide a wildlife corridor as well. We've got, in this township here, we have a $10 million bill related with removing nitrogen and phosphorus to meet the Chesapeake Bay tributary strategies. That could be either done utilizing an upgrade to a plant or a new plant, or something like this could be done to offset that cost. It may not be 100%, it could be 20, 30, 40, but in the meantime we're getting a benefit of maximizing and stacking credits here. The private sector itself, dealing with traditional stormwater management issues. If we can provide incentives in the market to drive stormwater in a different way, instead of only dealing with it on the site, a project like this could deal with it on a regional perspective, and it can be shown quantitatively that it's effective, it's economically feasible, and it enhances the environment. We had the opportunity to take a look at some of the problems associated with legacy sediment that is really ubiquitous. It's all throughout the state, and the problems that it's occurring. And this site, the Banna site, really shows some of the positive opportunities for restoring the floodplain a different way, a different approach, and the benefits, the multiple benefits that this technique really brings. It brings the stormwater aspect, the groundwater infiltration, habitat, potentially open up markets for the private sector, and from a larger scale outside of the region or even the state, we're dealing with issues such as global warming, carbon footprinting. These types of restorations provide the opportunity to bring in plants, bring in the opportunities for a footprint to be improving. And that is the proactive part of change that we're looking for. We have issues in front of us right now that need to be addressed proactively. This is one of many we have to look at. As part of our efforts with the floodplain restoration, we've put together an educational booklet that we feel as though will be helpful to wrap up a lot of the things that we talked about here today. That included interviews with a lot of different academia and other folks that have their own viewpoints on this, and it would be a helpful document to take a look at. With that, I thank you for the opportunity to address the legacy sediment issues as well as the floodplain restoration technique. Thank you.